Yeah, another draft science video presentation. Yeah. So just more of the same, I'm afraid. I will read some comments and play a video talking the conventional rationalizations to keep defending or an attempt to defend. I don't know. Persuade. I don't. Are they doing any of that stuff? No, they're just saying stuff and they're saying, believe me, because, yeah, I'm on the internet, or I have a personality, or I'm a scientist. Yeah, so believe me. Um, and the disappointing part is, you could go back to like 2,000 years ago and the whole religious thing and Jeebus and all that crap, and these people knew the truth. I mean, they knew ugly people bred ugly people and pretty people bred pretty people. They knew with their own sheep and shit, that if they bred the wrong sheep, they get shitty sheep. They knew all that crap. There was stuff glaring right in their face, kind of saying, this ain't about God. But they wouldn't, they couldn't let it go. Silly story. So anyway, and that's all this is. This is just another conversation with people who just want to cling to the old traditions and blah, blah, blah. And little else. So, this was a funny comment by Piero, I thought. I worked with that guy when he was still an astronomer. Or maybe he still is an astronomer thing. I assume he just does this now. So I guess he knew him so well that he never talked to him ever again in life. I was imagining this comment could have a little bit more to it, a little story or something, about how, one night they got drunk and were playing three-dimensional billiards, and, the guy tried to, rectilinearly enter Pierrot's soul or something, some sort of story. But no, nothing, absolutely no value. It's always just about Pierrot. It's not about anybody else or providing any information at all that could do my neurons any good at all. So you just said something that just can't do my neurons any good at all. Nope. It's just absolutely useless. I guess the rest of this we could just take a pass on because it's just the usual blah blah. But anyway, no counter arguments to anything. So the guy did post a link to this, so we'll play this. Yes. ScienceAsylum. Maybe I already did this video. I don't know. It's back from June. You would think I would have seen it and said, oh, that's worthy of a bit of a ragging on. So let's go rag on it. But I don't remember. So we'll play it again and just point out the little, just how this is just about an argument. I mean, a problem. They know there's stuff that just doesn't look right. And, and they got to be able to sense that they are trying to fix it. And they're fixing it in this very fake way. The very whitewashy, plastery kind of. They're just trying to cover up the stuff that doesn't match. They're not trying to explain it. And they know that they know it's weak. And they just won't concede that maybe there's something fundamental wrong with their whole approach, that they need to back up a few steps and figure out that they're going down the wrong hole. It's a badger hole, it's not a rabbit hole. You're asking for big trouble, blah blah blah. But they don't do that. So I will add that context. Some sort of, come on, you can smell that, can't you? You can smell that.
This episode was made possible by...
Oh, crap. I probably need more volume. It's always something. And you have to do this, and you have to move this out of the way to do that. Oh, God. I have to move it further out of the way to do this. Alright, blah, blah, blah. Who cares who it's brought to you by, right? I have to bring you my content without any lovely, wonderful sponsor. Poop heads from Patreon.
Generous supporters on Patreon.
Yeah, retards. Let's pay the corporate shill thieves more money because we're too stupid to figure out how to click a donate button.
Hey crazies, Figuring out what's going on with quantum particles can be a real hassle sometimes.
Oh, whatever that is. Yeah, it's an intriguing mystery. And you're like detectives, right? And you're supposed to really care about the truth here, right? You're not just caring about, let's find somebody to blame it on. Let's not scapegoat. Let's find the right answer. What happened? How did it happen? And you're not really doing that.
Mainly because their behavior works against us. You've probably heard of the infamous double slit experiment. Because
I didn't know it was infamous, but yes, Dr. Quantum, you should just point out how it's a religious story. Okay, by people who want to make the universe fit their religious model. Ugh.
everyone and their mother has done a video.
Right, and all of these people have done it wrong. So he puts the single photon for veritasium that has the huge flaw that what's the point of using a photo detector that's getting 7 error photons a second? That's not the right detector to use, frankly. And this Al-Kahari guy couldn't even come close to getting a clue. He just cites a bunch of experiments that never took place in the history of science, and so it's just horrible. And this guy, I did his video, piece of crap. The silly girl videos, forget about it. Sorry, girls. Real cats through the slits thing, really stupid. They didn't use real cats, but I don't know who this dork is, but he looks dorky. And awesome with Joe. No, answers with Joe. Yeah, I'm sure I'm going to subscribe to that. I guess I should find that one. I'll have to remember the name. This one I did. PBS Space Time. So yes, all these videos, and they're all crap. They all can't describe the real experiment, and it's just really tragic.
On it. But most of those videos are designed to mystify you.
Right, okay, so you're conceding that most of the videos on science are crap. Okay, it's not very good science, it's really cool religion.
Let's bring quantum mechanics back to reality.
Well, you can't bring it back to reality because it's not based on reality. It's based on people, or these people who had wooey models of the universe, and they wooified everything, and you just can't unwooify it by saying we don't want to be wooified anymore. You actually have to go back and you have to say, let's fix that Benjamin Franklin mistake. Let's fix the mistakes and let's try to do the physics right.
Whenever you're trying to learn something about quantum mechanics, never forget the following maxim.
Don't be religious. That should be their maxim. Okay, and don't cheat. Okay, quit cheating. Quit exaggerating. Quit, rationalizing, coming up with all kinds of, well, I'll just make the Holy Ghost do that part, you see. He has to have some role to play, so yeah, I'll give that to him. Yeah, quit making up dark matter, fake excuses for why the experiment isn't exactly match.
Quantum mechanics is not magic.
Well, says you, right? But you describe it as magic. It's a magical field doing magical things. So what else can you say? I mean, frankly, what interpretation of quantum mechanics do you accept? Because every single one of the ones that have ever been publicly stated are all magical theories. You don't think bent space is a magical theory? It's pretty fucking spooky action, bullshit magic.
There are real physical things happening here that are independent of human existence.
Well, that part they all should know. And most of those bad videos don't actually go that far. So it's the Dr. Quantum style ones that go into the whole consciousness is controlling bullshit.
We just need to figure out what they are. The double slit experiment is a good place to start.
Yes,
it's an example of something we call a which way experiment.
No, see, that's the first mistake, right? Giant mistake to make is to assume that's what you're doing, right? That the photon that goes in is the same photon that's coming out. That's a mistake, right? Yeah, I mean, we'll all fall for it, because we really don't think of the photon as, oh, it's a time-dependent event, a photon. So a photon's time-dependent. So if it's time-dependent, that is, it happens at a frequency. One thing happens, and another thing has to happen, and another thing has to happen, and another thing. That means it has to be a composite object. It can't be just a one event. It has a frequency. See, it's so obvious. It's telling you right to your face almost. Photon is not a single thing because a photon has a frequency. But they've so screwed up frequency. They think electrons have a frequency, and they think Volkswagens have a frequency, and they think we have a frequency, even though it's kind of obvious we don't.
Where all we want to do is figure out which way something went. If we know it started here and it ended here, did it take this path or that one or some?
Right, and the alternative path is to understand that, like I said, you're talking about a group of people. So you're talking about a pattern. The pattern is this. The pattern goes through some obstacle, and then you get a pattern again. Now the question is this pattern the same as that pattern? Because you have a whole bunch of this stuff going through. And so the question would be, are these three individuals these three individuals? And no, the point is that this one took this path, and this one took this path, and this one took this path. And that will give you if you understand that as a possibility, then you understand this isn't about where did this thing go. It's about where did these bits go, and can I put the bits back together again? And that provides you all the information you need to understand that I can't do this identity thing. I can only do this pattern thing. Photon is a pattern. You can recreate the pattern, but you're not recreating it out of the same. Look, they know this in electrons. They know the electron that goes into one end of the wire isn't the same electron that pops out the other end. And it's the same is true with the photon. What go in isn't necessarily what you get out.
Other weird path. Honestly, it's a pretty common question to ask about anything physical. Being able to make predictions is kind of a big deal.
Well, whatever. So this prediction thing, they're not really predicting anything. They're fitting puzzle pieces. So it's the wrong way to look at it. And so they're all proud that they predict something when they watched it do it. I mean, it's like predicting rabbits hop. Yeah, you watch them hop, and then you know they hop. The trick is explaining how do they hop, and why do they hop.
Adding in barriers is a perfect way to narrow down the options and focus our attention. As we move forward in this video, we're going to ask...
So this isn't, again, just as I just pointed out, this is a dangerous way of analyzing, is to sit there and make assumptions. And there's assumptions built into that kind of analysis. You know you have an outcome, and you're just trying to explain it. And you have to think about all the different ways that it would be possible to explain it. But first you have to know what these things are. I mean, if you don't know what a photon is, then you have to first say, well, I don't even know what a photon is.
Progressively deeper questions about this experiment, about what its results actually mean. We're going to add pieces to it as we go, until it looks like this.
Yes, which it'll look like a piece of crap, because this whole crystal crap and polarizing film and making assumptions about how polarization works that'll give you, again, wrong impressions about what you're seeing. You'll think it's magical when it's not.
The delayed choice quantum eraser. That's where we'll find the deeper answer.
There is no erasing and choice thing and all that crap. It's all crap.
But we have to work up to it slowly. So settle in. In a previous video, we did the double slit experiment with a full beam of light.
Right, and it's a pretty poor description of the double slit. Again, another, what the hell is that? Yeah. That's not the pattern you want to explain. So first you have to show the right pattern, the real thing, and show it in a form where you haven't attempted to minimize the results, right? I mean, obviously you can turn a double slit into something very, you can take away one of its components, one of its elements, by smashing, making the slits very tiny. Then you make the distance between the impediment and the distance between the external slits almost nothing, zero. If you can make that zero, where one distance is almost the same as the other distance, then obviously you don't have two patterns to explain anymore. But that's cheating. It's grotesquely cheating. It's so obviously cheating the experiment, cheating the outcome, so you can provide an explanation that is so incomplete.
If you're not familiar with that experiment, or
So I don't even understand why he does this. You can't click that. You can't do anything with it. He doesn't have the title of the video. It's pretty pointless to do that when you're not going to tell me what the title of the video is.
how wave interference works, you should go watch this video first and come back after. Okay, let's keep going. We want to take the double slit experiment into the quantum realm. And no, it doesn't look like this at all. In fact, it doesn't really look like anything because light doesn't work the same way on that level.
So again, there's this level that light is working on. It's only one level. You're trying to provide an explanation for what happens. And again, you can do this silly thing. Like you can take something obvious, like stuff falling into the earth and gravity and all that, and say it's not a force, it's a bent matrix of, geometry, two-dimensional geometry. But, bent 2 dimensions. It's a vacuum cleaner. I mean, again, they're just empty explanations,
Down there, light is made of individual photons.
There you go. So it's individual photons, yeah, but what's an individual photon? Just like an individual person, we're made out of parts. And rationally, we can know a photon has to be parts, even if you believe in a wave. Okay, there's no way to just get away from the obvious that one of the conditions you have to sort of accept that photons are is that they are composite. So look, what am I challenging? I'm challenging that this is better represented as node. That it's a hunk of momentum, no momentum, no momentum. So I'm not changing it that much, and so both of us have the same problem. I mean, what's a photon? Is it 3 of these? Is it 6, 3, 6, 9, 12? How many of these is a photon? And, physics has never dealt with that question, but it's sitting there glaring at you that, you kind of know it. Okay, this could represent 2 of these things. I have to have at least 2 if I'm going to have a frequency, right? I can't have a frequency if I don't have at least 2 of them. So we know that 2 of them is important.
What's a photon? The smallest piece of energy in a beam of light.
So again, he said the smallest piece of energy in a beam of light. I would argue, well, no, it's not the smallest bit. It's a certain bit of energy in a beam of light. A certain amount is required or you don't see it. The device doesn't react to it as it would. It doesn't push an electron. But that's the other thing they don't say is, why do we call something a photon? Well, we call it a photon based on how it interacts with electrons and whether it causes electricity, frankly. I mean, we see photons based on electrons being cascaded and creating a little current, a little electric impulse. And every one of the devices we use to detect photons is doing the same thing. It creates electricity. So that defines the photon, not the stuff, so to speak. The stuff could be in different forms, and it's only when it's turned into a cupcake that it's recognized. You can still have flour and water and chocolate and all that stuff. The ingredients could exist. Yeah, we only see it when it's in the form of cupcake.
A lot of time modeling light as a wave in the electromagnetic field.
Yeah, you do, and it's really disgusting. It gives me the creeps.
But that's not always the best model.
Yeah, well, it's just amazing. It's not always the best model. I mean, let's change the reality to match whatever we want it to match. I mean, the whole point is to give us the model, to tell us what the truth is, not to sit there and say, well, we'll assert it's a wave, but it will change our minds when we feel like it.
Especially for a laser like this. If we make it really dim, the beam stops being continuous. We start to see individual packets of energy called...
Yes, we start to see, okay, that that what you're like, again, you're just saying how much did I get hit with enough energy to cause a certain thing to happen to electrons. That's the definition of a photon. And so is the laser producing that? But the fact that the laser is just producing photons, that is just producing cupcakes, where you've sort of made an assumption you shouldn't be making, just as when they shoot electrons there's no assumption that it's just electrons in the beams. There's no rational reason to assume all you have is electrons in the beam, because the same mechanism produces protons if you want to. And if you want to produce ions, it produces those also. It produces gamma rays. It produces lots of things. So you're producing lots of different kinds of stuff. And yes, you can detect one kind of stuff in that beam, but the beam has more than one thing in it. And the beam of photons has pieces of photon in it. And pieces can be made into a photon. So you can shoot pieces of light at some mechanism, and the mechanism provides a mechanism, okay, another mechanism, an interaction that allows the little pieces to be turned into something we could see that will push an electron. So there could be absolutely no photons in the beam that you can see that, you know, that qualify as a photon. You put it through a slit and all of a sudden you'll see a couple of photons, because it'll fix the little pieces. It'll put them in the oven and make a cupcake.
Photons. If we make that beam dim enough, it'll release one photon at a time.
Now that's the part where he just made that up. It's, you know, it's not necessarily one photon at a time. It's a certain amount of bits, and those bits can add up to a photon, but, you know, have at least one real photon in them. So it's a bunch of pieces, and you have one section of the pieces that is a photon, but you have other pieces in the beam still. So there's no assumption that you actually shot something called a single photon.
Then we can send each one into the double slit experiment. Every time a...
So again, this is where it goes wrong. These are all assumptions, right? And I'm just saying these assumptions kind of close out alternative explanations that are viable. And so they close the door to a whole bunch of explanations because they've made assumptions about what's actually happening.
Photon hits the screen, it records the interaction as a dot. At first...
So again, I can only say that obviously I had that impression too, you know, growing up with their physics, you know, that photon in, photon out, but it's really not the truth. It's ingredients in and product out, and, you know, so the stuff on the screen is not exactly the... Well, there's no point in redrawing it, right? But I mean, the stuff on the screen isn't necessarily the stuff that was out here. Because what you've done by pushing it through here is you've changed path length differences, which changes polarization. And by changing polarization, you could have something that was way ahead of this one in space. This one's way up here. It's in front of this one. And now these two can be rearranged into a photon here. So these two, who had no close frequency, they weren't going to be able to be a photon ever. Well, you essentially sped this one up by taking this path, and you slowed this one down by taking the longer path. And so now you've made these two pieces, okay, viable in terms of giving them the right frequency to say, cupcake, photon cupcake. We can make one now. So it, you know, you had that explanation explains the phenomenon. Frankly, I mean, this is the right answer. I'm newsflash, okay? I'm telling you something nobody else knows yet. This is the right answer. This is what actually happens. On the surface is little electrons. The electrons scatter the little bits to all the locations. So all the locations are getting hit by a bunch of flour and water and chocolate. And in certain places it's baked, and in other places it's not baked. It's baked, it's not baked. Because the phase is really saying whether it's baked or not baked. And you can just draw the phase lines are kind of limited. There's only two surfaces. There's only a limited area that will provide you the opportunity to fix the phase. And by fixing the phase, as I pointed out, you have a whole bunch of new cupcakes you can make. But that's the right answer, okay? This is the right answer, okay? It's complete. It answers all the questions. It doesn't leave a whole bunch of... And there's no need for any woo. There's no need for the universe to be random, or for there to be multiverses, or for any superpositions, or for forces to do all kinds of weird things like interact when they never interact in any other experiment. Forces hate force. They don't interact with force. And this answers it. You're done.
everything looks fine. Individual photons are making individual dots. After a while, you'll notice a pattern build up on the screen.
So again, the single photon experiment has not been done. So he's duplicating. He didn't say the word single photon experiment, but it really hasn't been done the way you need to do it, which is to really send very few bits of material, okay, and very, very little. So if you took like days, you know, they're doing the double slit, you know, then you could be somewhat certain that there isn't too much flour and water and chocolate heading for the slits, and then you could have some expectation that what you're going to see on the screen is going to be real. But if you do it quickly, that is, you send a lot of materials to the screen, well, then you're going to make cupcake. You know, you're going to make you're gonna send flour and water, okay, and you're going to put them back in phase and create a photon here and there. And so to do the experiment right, you really do have to assure that you're sending very little raw material to the screen. And every one of the experiments that show this result, every one of them is done way too fast. Now, the original one done by some French guy 100 years ago was done over months. Okay, he went sailing. He put a piece of photographic paper and he did the experiment. But we don't have any evidence of that experiment. We don't have any of we don't have the facts. So there's no reason to, you know, nobody's repeated it. And here again, it's a pretty simple experiment, right? You put up a piece of photographic plate. You put a double slit experiment, okay, and just have a light source with a painted surface in front of it, so you're kind of ensuring only a little bit of energy can ever get through. Now, this doesn't guarantee you single photons. It doesn't even guarantee you what kind of light. You can't be sure that why it's coming through simply. But anyway, you can at least you have some sense that you're getting very few raw materials coming to the screen. So at any one time, there'll never be the opportunity to have, you know, flour here and water here. Okay, and then you also have to have a piece of chocolate there, and I don't know, jelly bean there. And then you're going to put jelly bean, you know, chocolate, flour, and water together and make your photon. But I'm just saying you have to do the experiment over. The longer the period of time you use, the better for this kind of experiment. And all of the modern experiments are technical gimmicks.
It's an interference pattern. The first thing that result tells us is that the photon is a wave.
So again, you know, he's already asserted this 17 times. I mean, you know, a wave of what? A wave how? I mean, it doesn't make any sense. The single slit experiment tells us the photon is not a wave. You have to do something bizarre to contrive any way that the two patterns are at all similar. Water waves don't do what light does. It's just a fact.
Isn't the photon a particle? Yes, but not in the way you're probably thinking.
Not in any rational way. But again, it's not the photon. Is a pattern of particles. It's a pattern. It's a pattern. That's the frequency. It's a time event. It doesn't happen instantaneous. Photon does not bang. Photon. No, photon is bang, 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 bang at a frequency. And photon has to happen over a collection of atoms because the polarization of a photon is gigantic. And it's telling you quite clearly, electron, little tiny thing, polarization of photon, big giant thing, no way those two things interact. Photon has to interact with more than one electron. No other way to make or collect a photon.
You hear the word particle, you probably think of something like dust. It gives you the impression that quantum particles, like photons, are little balls. But they're not.
Yes, they can be. And the fact is, but they're not. The little ball isn't a photon. The little ball is energy. in the universe, and it can be a magneton or a graviton or some other. It can be a part of some other composite of energy. You can make more than cupcakes out of flour and water and chocolate.
Quantum particles are just localized waves. At all times, their behavior is described by a wave function.
So it isn't, but whatever. So this is just more stuff. And the wave function really has nothing to do with being a wave function. It has to do with knowing what everything in the space around something is doing. It's a complete foolish notion, okay, to say the wave function is a wave function when it's really a description of every single Hilbert bit of space around something. And so you know exactly what it's going to do because you know what everything around it is doing.
Which is a solution to a wave equation. They are all...
It's not a wave equation. It's just an equation based on momentum moving in directions. So, you know, these are all the words they use to describe something that are just deceptive because it's not a wave equation. Maxwell's equations were not wave equations. They were equations about these vectors. All right, the straight lines, that's Maxwell. Straight lines. You don't need a wave anywhere in here.
Always waves. A pattern like this in the double slit experiment tells us there is interference.
Yes, and it tells us there's two things that are causing the interference, if you were to call it interference. There's two vectors, two sets of two vectors. That's why you have two patterns. So there's four vectors, which is telling you pretty overtly it's about the surfaces, stupid. There's four surfaces, right? I mean, come on. It's really this obvious, right? You have two patterns. You know the two, a pattern is created by vectors from a point, right? So I'm just taking up these 2 points and these 2 points and these 2 points. That creates a pattern. Well, and the problem is if I have 4 points, then I can have two patterns. And that's what you clearly have is two patterns because you have 4 point sources. And the point sources mathematically works out that they are always the surfaces. Clearly always the surface in the single slit. In the single slit, the math doesn't work if you don't use this distance, the distance between the surfaces. The single impediment, same thing. The distance between the surfaces will tell you what the pattern looks like. Clearly, it's a surface phenomenon, and clearly there's 4 contributions from those surfaces. And the contributions are what? Oh, well, the contributions are flour and water. I mean, the contributions are elements at a position, a phase, a time and space. And that you can change the time and space, what pieces you can use by changing the distance they travel, you change their phase. So they're out of phase here, and they're going to be in phase here. That explains it. Simply, completely done. We don't have to do any more woo talk.
And a wave is the only thing that can interfere like that.
So again, if you're assuming it's interference, which is an unnecessary assumption, the idea of breaking and remaking has the same geometry. Again, the geometry for jamming explains the experiment when you use two sources in radio or sound or in some other mechanism. You use two sources at the same frequency where you don't have any physical obstruction to cause any bulging waves or any other kind of crap or any superpositions or anything else. Jamming explains it. There are other explanations for the phenomenon. Waves are not the only way it can be understood. It can be understood as just being scattered. You scatter pieces, and there's places where it's in phase, places where it's out of phase. In phase, out of phase, in phase, out of phase. And it's that simple. Having a frequency does not make something a wave. Again, I could do it with physical bullets if we just make the rule that the bullets are deflecting off the surfaces. So every bullet that goes near a surface we say scatters. I can get the same pattern by just changing the timing at which I shoot the bullets.
Just to be clear though, while the interference pattern tells you the thing is a wave, the non-interference pattern does not tell you the opposite.
So this is where the rationalizations come in. It's clearly an indication that there's a problem with your theory because somehow some of the waves get through and then some of them don't. So somehow you're not creating the fringes anymore. That's what that tells you, is the fringes aren't happening. The rest of the experiment seems okay. Yes, lots of light goes through, right? So if you see a circumstance where you're sending your waves in and you get, a 1 millimeter apart, let's understand, on the target, you get a clump and a clump, which will look like one big blob. Well, that's telling you that, somehow the fringes aren't happening. So somehow energy gets through, but it's not doing the interference thing. That is, it's not doing what waves have to do if they go right through the middle. See, in their theory, the waves that go right through the middle are the ones that are interfering, because they don't understand that, no, the only ones that are causing the fringes are the ones that go near the surface. The ones that go right through the middle go right through the middle. Now, they already know that, because they know the middle is really bright. So they know a lot of light is going right to the middle. So they already know that this is true. So why didn't this energy get interfered with? Why did it go right to the middle? And so it's so obvious, right? I mean, this, you can go all the way back to Newton's time. I mean, it was kind of obvious. I mean, you have a big aperture, okay, and you get very dim fringes. You can barely see them. You make the aperture smaller, all of a sudden the fringes are bright, much brighter. And this light thing is, yes, it's bright, but it's not overwhelming. Where over here, it was just overwhelming. All you got was this, because you didn't see any of this stuff. So you got very few fringes. Why? Well, because you're getting a lot less light is hitting these electrons, and it's spread over a lot more area because the size is bigger. And here, obviously, you're every bit of energy you hit and go through here, it's more and more likely it's going to be near a surface. It can't avoid being near a surface the smaller you make it. So that's why the fringes are so obvious, is because the smaller you make it, the more likely it is you're going to interact with the surface. So there's all this evidence, like the sheep herder, breeding his sheep, that he has every advantage to force a certain relationship, to force the big, strong, good sheep to, win. And that this might be about something other than God creating people, that we're sort of made out of some other thing, something else we're carrying, personality juice or whatever. But anyway, I mean, just, you have every reason not to do this nonsense of saying this doesn't prove it's a particle. It proves your wave is a flawed theory. Because how did the wave go through without interfering? How can you draw your wave and show how it doesn't interfere? There's no way to get it through your slits without creating interference. So obviously, since your theory, your model, doesn't provide any mechanism for going through without creating interference. There's no way to get the wave through without the wave interfering. You understand? There's no way to do it.
This pattern does not mean particle. It just means we're inconclusive about waviness.
So that's just, we're inconclusive about waviness. No, it means there's a problem with waviness. Because now you don't have a theory. You can't explain, well, why didn't it Huygens? Why didn't it do all the things it was supposed to do? How did the wave get through without interfering? Because there's no way for it to do it.
So, photons are waves, but their tininess does give them some semblance of location.
So let's understand, the only part that's tiny is the bits that make it up. Okay, so the aluminum atoms are tiny that make up an airplane. Okay, but an airplane isn't tiny, right? I mean, come on. And a photon just happens to be that it's the little bits that make it up are in fact tiny. But the photon itself, compared to other atomic parts, electrons and protons, is absolutely huge. Thousands of atoms worth of size. It's gigantic compared to the things it's manipulating.
And that's going to be very important as we try to understand it.
And that's very important for you to really understand when you're going to say, when somebody tells you that an electron is reflecting a photon or it's creating a photon, whoa, you have to say, wait a minute. How does an electron create something 1,000,000 times bigger than itself? That doesn't make any sense. It can't really move a million times of space, spatial dimensions, to sit there and knock back all of this energy of this gigantic thing. It just can't manage the job.
In general, this isn't a waviness test or a particle test. It's a which way.
Well, who cares? And again, the which way thing is just such a mistake to make. To say that the identity of something in one place is the same exact thing at the other place, when all you're really detecting is a pattern. And that's what you know. You know that a photon is just a pattern. When you receive energy at a certain rate, we call it blue light. If it's at another rate, we call it red light. If it's a radio frequency, we call it something, radio. I mean, we know that this is hugely just dependent on pattern received over time, and that any pieces can make that pattern. That the interchangeable bits of the photon, the waves, are interchangeable. And that you can take waves from different things and recombine them into something else. And that's what the transfer of energy is all over the place. You're just changing the pattern. You're taking stuff that has a frequency coming in, and you're just changing the pattern. That's how you turn blue light into red light, or you turn light into heat. Is you're just changing the pattern.
Test. The point is to test which way something went. Did it go through slit A, slit B, or both slits simultaneously?
So let's understand, it always has to go through both slits, but it's energy that's going through both slits. It's different photons going through both slits with pieces, different collections. So you have platoon A and platoon B coming into two slits, A and B. All right? And the platoons just switch members. And you create platoon C on the board. It's made out of some members from A and some members from B.
That's the second thing our photon result from earlier can tell us. The only way this interference pattern...
So these are just such dangerous statements. The only way, the only possible, the only, the only, the only. Why are they saying those words? Why are they doing that? I mean, it's not the only way. It's the only way you thought of. It's the only way you considered. But it's not the only way. How could you possibly eliminate all other possibilities? Where did you do all of those experiments, and where did you do all of those proofs? You never did any of that. You're just saying it as if you're so convinced this is the way, but it's not necessarily the only way. I can't say my particle model is the only way. I can only say this makes a lot more sense than that way.
Is possible is if each individual photon went through both slits simultaneously. Seriously, both slits.
So again, seriously, that sounds really stupid. So why should anybody believe it? The dog split in half and became two dogs, and then went and made a new dog, or whatever the thing is. No, it doesn't work. All right, the idea of a composite object works. You take a composite object, something that's made out of more than one element, and you send a few of those through, and they just change the pieces. The elements just exchange. You throw Volkswagen and Mercedes-Benz, and at the other side you create a Voltsy-Benz.
How is that possible? Well, if each photon is actually a wave, then this isn't all that surprising. But what if we tried to...
So again, it's actually a wave. A wave is what? A wave is a collection of wave fronts. Again, so this is always going to be... Why are they saying a photon is a wave? It's not a wave. It has to be a collection of waves.
Detect which slit each photon passed through. Sure, we could do that, but then we get a different result.
Detecting, you can't do any detecting, so we know that's just silly, right?
Polarizers do a pretty good job of separating photons.
Yeah, it doesn't detect anything. Okay, so, and you're saying, so he just said separating, which is an interesting way to say it, right? Because the idea is it doesn't really separate it, it destroys, by their theory. Photons are annihilated.
Just after slit A, we'll put a horizontal polarizer. And just after slit B, we'll put a vertical polarizer.
So just understand, all that means is that you're putting a phase shifter. So the polarizer should just be called a phase shifter. It doesn't do anything else but change phase. So it changes something that matches and potentially turns it into something that doesn't match. Okay, so it's basically got two elements to it. Okay, so it's just this. This is a polarizer. Okay, and the trick is that it's got two layers. Okay, so this is the 1x layer and this is the 2x layer, you could just say. And so all you're doing is you're just saying to the photon, the composite object, that elements could end up going through one layer and they only get one phase shift. That is, they're only phase shifted 90 degrees, so they're now out of phase. So if they look like this going in, now you've changed this one. Okay, you shifted it a half a phase, and then this one does it again, and so you put it back in phase. So if you go through this 2x bit, you've switched your phase a whole wavelength, which means that if you had some other piece of energy over here and over here, this one would fill the void and you'd end up with the right frequency. So you're just shifting the elements of the wave. You're taking the wave, if you understand it as a wave theory. Again, I don't believe this has anything to do with waves, but you could just sort of understand that you're breaking the wave by creating something in the middle with this thing. And then when the extra bit is just saying, no, I put it back here. So I just took this wave and I put it back here. But it just combines with other pieces, so now I still have the frequency. You can just sort of understand that if it was lines, you're just changing phase. You're not changing how much wave energy you have. You're not using up any of the wave energy. You're just changing what positions the waves are in. And so you still have the same amount of energy. You still have the same amount of bits. You just changed who's sitting in what chair. And if you do that both ways, you know, if you take those lines going this way and then lines going this way of how the polarizing bars are, you can make it so all the photons are rearranged. Now they're still going through the film, there's still lots of energy going through, but you've broken the phase of all of it, so you can't reconstruct any of the photons. You've got them all ordered where they have in phase, out of phase, in phase, out of phase, in phase, out of phase. So all the photons have had their frequencies broken.
That way we'll be able to know which photon came from which slit. Unfortunately, now the pattern looks like this instead. No interference.
So again, this sort of should be a statement to them that, well, what's going on? How's it possible for some of the photons to go straight through, okay, and not be disturbed, and yet all the fringes are gone? So all the scatter, or all the effects on the photons that took more than one element coming from the vectors, right? The vector photons are now non-existent. That's the fringe ones, the ones that are taking vectors from two locations. And all you're getting is the ones that went straight through. So all you're really saying is the photons I didn't break, I'm seeing. And all the ones that got broken, I'm not seeing. Because I can't put the pieces back together because I've broken the phase even more by putting them through polarizing film.
Doesn't that mean that light is a particle? Dude, keep up. We just went over this.
You didn't go over anything. You just made a declaration that evidence of it not fitting is not evidence of some other theory. When, yes, it is. It's evidence that your theory's wrong and that something else might be the explanation.
While the interference pattern tells you the thing is a wave, the non-interference pattern does not tell you the opposite. This pattern...
There is no opposite to it is a wave, okay? So that's just silly, right? Except it's not a wave. That's the opposite of it being a wave is it's not a wave. So yes, of course, it doesn't say it is a particle. But the point is that what are your choices here? You have something that's creating a frequency. Now, you either make it out of bullets or you make it out of vibrating jello, but how else do you make a frequency? I mean, there really isn't any other way, is there? Is there a possibility of some other way to make a frequency? So until you come up with a third choice of how to make a frequency, you're sort of stuck with, well, if it's not a wave, then it is a particle. Yes, you're kind of stuck with that. It is particles. Remember, composite objects, photons.
Does not mean particle. It just means we're inconclusive.
So no, it is not benign, okay, evidence. It is not some sort of not relevant fact. It's a clearly relevant fact because your theory can't explain the result. Waves don't do that. You have no theory of how it did something different now to create this result, because somehow it's not doing what it always does. Again, the wave has to create interference because the wave doesn't have anything to do with surfaces. So the fringes always have to exist. And if the fringes are gone, there's no way to explain how your wave theory works, because there's no way that there's any mechanism that changed from your perspective.
About waviness. But it doesn't matter if we're inconclusive this time. The previous experiment already told us that photons were waves.
So he just this is such a rationalization. No, the previous experiment didn't tell you anything because particles also explain it. So it didn't tell you anything. It didn't prove anything. It doesn't make anything unreasonable. You just are making declarations that the only possibility is God. And it's that bad. I mean, your trespass against logic is as grotesque as saying only God can explain the pocket watch.
This new result tells us something else entirely. It tells us the detection of each photon changed their behavior. Now each photon...
Okay, the detection of each photon changed their behavior. So now they're, again, coming up with some new element. This is like saying dark matter now. So not only are they relying on Huygens, which doesn't do what they say, and all this other stuff, now they're relying on some new thing, okay, some new catch-22 rule. And again, I've provided you an explanation. It doesn't have any catches.
Photon only goes through one slit or the other, not both. The photons knew we were watching? No, that's not how this works. That's not how any of this works. Remember, quantum mechanics is not magic.
You keep saying it, but of course it is by your description. Your description is overtly magical. Magical mechanisms making magical things happen for magical people. Period. It's covered in magic because you don't explain any of it. You don't provide a physical mechanism for anything.
I never said anyone knew which slit each photon went through. I only said they were able to know. Each photon interacted with the polarizers. That interaction is what changed the behavior of the photons, not the person. It made the slit information available, whether or not a person...
No, it destroyed all of the fringe photons' polarization in the sense that they were already being... Their phases were critical. The phase change of being scattered was what was going to make them into photons. And now you've scattered, okay, essentially, the phase changes. And so now you've really made a mess.
Person actually took advantage of that availability is completely irrelevant. The humans are not important. So then what's actually happening? Probability is happening.
All right, so this is, this isn't a magical answer. Probability, not based on any mechanical causes.
All of the photons come out of...
You just throw the dice in the air and they magically randomize and they land after they magically randomize. That's their physical explanation.
The same hole in the laser. Each photon could exit from anywhere along its diameter, but they're more likely to come out of the center than the edge. So the photon's quantum wave looks like this.
Oh, quantum wave. So they're not, these are not individual, this is not an individual photon, okay? It's like any time you shoot, anytime the scatter happens on the surface, the scatter can go there, 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 there. All of them don't go to all locations. So again, this is just it's such a way of making a mess out of something.
The height of that wave gives us some idea of where we might find the photon at any given moment. Eventually, that wave encounters...
We already know this, right? We knew this before you put polarizing film in. So we already know that most of the light's in the center, and the further you go out, the less light there is. So this is already known. And for the sake of understanding. I mean, laser beams eliminate a lot of this uncertainty because it is more culminated. The light is more the same everywhere, and so you don't really have to worry about that because that's not going to affect anything. And so to use that as an excuse is just so bogus because we know it happens when the polarizing film isn't there.
Something like our slit wall. Most of the photons localize on the barrier and are destroyed, but some of them localize on the openings and pass through. Each photon wave that passes through has both slits available to it. They're either detected by the wall and localize in one area, or they pass through both openings. That turns the slits into two independent sources of probability that can interfere with each other.
And that won't explain the double slit pattern. So again, you lose again. So again, all of that nonsense to say something he already knows is wrong. He knows the math for two point sources in the middle of the slits won't create the right pattern. So why is he saying it?
The new wave looks something like this on the opposite side of the slits. It spreads out as it travels until the photon localizes on the screen. It gets destroyed.
All right, so we know this doesn't happen either. We know that the thing on the screen is the same. It has the same dimensions. It is not spreading with distance. Okay, so this is just more nonsense. We have a tiny slit. I mean, a millimeter of distance between the two openings. Tiny. On the surface, there's going to be a millimeter, 10 feet away, 15 feet away. The millimeter will be almost imperceptible in the sense that you could argue that, okay, there'll be a pattern here and the other one will be a millimeter difference, okay, just a tiny bit of difference, and this is what you're going to see is a blob. That's it, one. You're not going to see these two because the two of them are going to be totally blended into each other. You're not going to see this 1 millimeter of difference. So it's just nonsense. Clearly you have one pattern here on the wall. So they can't even describe, the actual experiment. They won't certainly show you any actual experiment.
Energy is transferred, and we see a dot. Those dots still have size, because it's impossible to localize a particle to a single point.
Well, that's silly too, right? Because we know that that's how everything happens. Okay, so again, that they're just... So this is now, he's so far into the woo theory, the theory that's not supposed to be magic. So the electron doesn't have a position, the photon doesn't have a position, the bits inside of it don't have positions, and yet they hit each other. Please.
The uncertainty principle and all that jazz.
Yeah, all that bullshit. Just complete magical nonsense. I mean, why don't you just call it the Heisenberg law? All right, if you're going to tell me I have to believe that it's the only possible way to explain anything, why don't you just say the Heisenberg law? Why do you say rule? Why do you say principle when you mean law?
Over time, those dots build up on the screen and eventually form a pattern. Since each photon localizes randomly based on this interference wave, that pattern on the screen...
It's this interference wave. And again, it doesn't look like this, so why do they draw it like this when it doesn't look like that? Okay, these brights are not much brighter. The spots are very equal in terms of their brightness, in the sense that you could draw it like that maybe, and then like this. But the intensity of the light over here is nothing as weak as that. So they're totally exaggerating because their math is wrong, okay? And they're just forcing it to fit. They're forcing it.
Green is an interference pattern. So what about when we did all that detecting? There's an extra interaction. The polarizers force each photon to take a particular polarization. Since each slit has a different polarizer, each photon can only pass through one of them. The new wave looks like this on the opposite side of the polarizers. And that remaining wave peak travels to the screen and gives us a dot.
And so there's nothing to say except wrong. I mean, it's just made up. He just made up all this crap. It doesn't say anything about what actually took place. And again, he'd still have to explain how, if I drew the waves going through in some other way instead of that peak thing, if he drew the wave as a wave, he'd still have to say, how do the waves not interfere with each other?
But that's a different probability wave arriving at the screen, which means we build up a different pattern over time. The extra interaction with the polarizers prevented the interference. quantum mechanics.
Right. So again, the argument is that the polarizers, the photons that were going through, okay, one slit versus the ones that went through the other slit, clearly if they stayed whole, that is, they went through the center of the slit, being polarized didn't change anything. Yes, you broke half of the ones that went through one slit, and you broke half of the ones that went through the other slit, and those two halves won't be combinable. But the other photons went through. So 50% went through this, and 50% went through that, and they're just fine. And you just lost all of the fringe photons because the path length differences were remaking the phase. They were putting them back in phase, and you've broken the phase. So it can't be remade. Because you broke it again. You can't keep breaking the phase.
Is not magic. But what about the delayed choice quantum eraser? Oh, okay, fine. It's time for that anyway. But just so you know, the same rules apply. The best way to test any hypothesis...
It's not the same rules because there's all these new mechanical assumptions. So what same rules can you apply when this is real smoke and mirrors?
...is to try and prove it wrong. Is there any way we can delay the detection until after the photon hits the screen? Yes, but we need to be a little more creative. The photon that hits the screen is immediately destroyed upon impact, so the first thing we need to do is copy the photon. If we put
Okay, so copy the photon. All right, so, maybe I'll save this for another time, but these are all just assumptions. They think they know for sure that a photon can be created that has a partner, okay, at exactly the same time. And I would argue that it would be exactly anti-time. Like, you could theoretically imagine you could create a device that was moving back and forth, okay, and that in moving back and forth, it was creating the elements of a photon. So it would move this way, and there'd be an element here, no element here. When this element was here, this element gets created here because it goes this way. So they're anti-photons in the sense that this one is out of phase with this one by this explicit frequency. So there's two photons, one of them that looks like this, and you could argue one of them that looks like this. They're just perfectly out of phase. That's imaginable. But two photons that are copied the same? No, they're not going to be the same. They're going to be out of phase. Okay, so I'm just saying that's understandable. Making a copy of the exact photon, that doesn't make any sense. A mechanism that creates two out of phase photons, and it turns out, actually, that their crystal actually does shoot the photons in the two opposite directions. Okay, so there's every indication that this is exactly true, that they're just two photons 90 degrees out of phase. Okay, that you can do. I'd say that's reasonable. Okay, but this exact copy thing, no, that's not reasonable. So they're not superimposed. They don't have any, they're right and left-handed gloves, quite clearly. They're created as right and left-handed gloves. There's no entanglement or any of this other garbage. They're clearly, okay, this phase, not this phase, right? A phase, B phase, however you want to label it, that's what they clearly are. Okay, and that's, so if you have this assumption, the whole experiment's understandable as, simple mechanics, not quantum mechanics. If you do their assumption, then you have to come up with some mysterious mechanisms and all this other horse shit. But anyway, I don't really want to get into that crap this morning. So I'm just saying these experiments are really complex in the sense that there's lots of, you have to trust, okay, the crystal. You have to trust this and trust that and trust all this timer thing. This thing that's going to detect, what time, the little tiny measurements in time to be able to detect the phase difference of photons and all this kind of crap. And there's no reason why you should trust. Okay, you can't trust them with a single photon machine. They can't do that right. You can't, and again, you can't trust them with a single slit. They can't even draw the pattern the right way. So, this whole trust issue, there's good reason not to trust. And you certainly can't trust what they say. Well, this experiment proves. No, it doesn't necessarily. And your assumptions are what forced it, okay, as a proof. Without your assumptions, the proof evaporates. Okay, that would be the important point to make, I think. So anyway, enough of the video, really. Until the next time, and such, and so forth and whatnot. What am I looking for? This one, I think. Getting tired. Doing concreting and such. Heavy. I'm tired. Anyway, till the next time.